All right, guys. Number 13, it's kind of actually a review kind of question. Y is a function on x such that y prime is positive, which means the function is increasing, and y double prime is negative, which means it's concave down. So we want to find something that's increasing and concave down. So I'm going to eliminate c because it's decreasing. And I'm going to eliminate d because it starts to decrease, so can't be d. And I'm going to eliminate E because it changes its concavity. This is part of a cup, this is part of a frown, so it can't be that. So now we just have to decide concave down. That was part of the frown, and that would be option B, part of a frown. All right, number 14. At time t equals 0, a jogger is running at a velocity of 300 meters per minute. The jogger is slowing down with negative acceleration that is directly proportional to time t. This brings the jogger to a stop in 10 minutes. Write an expression for the velocity. What is the total distance traveled by the jogger in that 10-minute interval? Okay, directly proportional. All right, so we have negative acceleration that is directly proportional to time t. So basically, acceleration is k times t, directly proportional. And we know it's negative because they're slowing down. Okay? This brings the jogger to a stop in 10 minutes. We also know its velocity is 300 meters per minute. So v of t is 300 at time t equals 0. And they want to know, the jogger is slowing down. It brings the jogger to a stop in 10 minutes. So at time 10, so v of t is 0 at time t equals 10. Now this is kind of an advanced question. Don't freak out. This is not on tomorrow's test, anything like it. But it is a good idea to kind of look at this and start going. If you really don't care, go ahead and just skip forward, because it's not going to be on tomorrow's test. But we should remember that when we took the derivative of velocity, we got acceleration. So if we want to get velocity from acceleration, we have to integrate it. Okay, so if we integrate acceleration, we're going to get back velocity. And you can see here, hopefully you remember enough about your, from what we have been doing, we can integrate a number times t. So if I'm going to take the integral of a number times t, I can take that number out, t dt, and you get negative k t squared over 2 plus c. That would be our expression for our velocity, right? Well, the great thing is we have two values for velocity. We know that when t is 0, velocity is 300. And we know that when t is 10, velocity is 0 because they've stopped. So we can put those two values in here to get an expression for the velocity and get rid of our two variables. So I'm going to go ahead and do this. Why not? I'm going to plug in time t equals 0, and I know that my velocity is 300, so it's 300 when t is 0. That would be 0 right there, plus c. All right, that was easy. Now I know my value of c, right? So I can plug that in. So velocity so far, we know that v of t is negative k t squared over 2 plus 300. And now I can also use this second piece of information to find out what k is, because we really need to know that. We know that the velocity is 0 when t is 10. So when you've got negative k times 10 squared, that's 100 over 2 plus 300. All right, let's just solve this really quickly. We've got 100 divided by 2, that's 50. So we got negative 50k plus 300, and that equals 0. So basically that should tell us, hopefully a little bit of quick math here, you got k is 6. All right, so an expression for our velocity, and this is where we will be going, guys. We're not necessarily there right now, but we could. You see, it's not that bad. It would be negative 6t squared over 2 plus 300. That would be the expression for my velocity. What's the total distance traveled by the jogger in that 10-minute interval? Once again, we haven't quite gotten there yet, but you should know now if I integrate velocity, if I integrate v of t from 0 to 10, I'm going to get the area under the curve, which we really want to be completely positive, and that will give me my total distance. I'm not going to do that right now because I don't want to get too far off track, but that's the idea. All right, moving on to 15, our final question. This is one of those like fundamental theorem ones that we had looked at before. The graph of differentiable function f on the closed interval from 1 to 7. In fact, this is very, very, very similar, if not the same question that we did in class. But let's see this. H of 1, so I'm just going to plug 1 in. So that would say the integral from 1 to 1 of f of t dt. Any integral from one number to itself is going to be 0, so that's 0. H prime, that requires us to take the derivative of h, which would be d dx of the integral from 1 to x of f of t dt, which is f of x. We should know by the fundamental theorem. So h prime of 4 is just f of 4, and f of 4 based on this graph is 2. Okay, on what interval or intervals is the graph of h concave up? Concave up occurs when we have concave up means f double prime, oh, not f double prime, sorry, h double prime. Let me erase that really quickly. H double prime is positive, which means that h prime is increasing. Well, since we know that f, right, according to here, f of x is h prime, when is f of x increasing? When x is between, let's look here, when's this increasing? From 1 to 3, 1 to 3, and from 6 to 7. That's when the derivative is increasing. And then find the value of x at which h as its minimum on the closed interval. Minimum, or when, and I am reading the word minimum, minimum is when the derivative goes from negative to positive, which is not here. This is a max because it's positive to negative. So our other suggestions are endpoints 1 and 7. And this is a min because directly to the right we increase, right? All this is increasing, whereas all of this is decreasing. So which one's the minimum? The minimum is going to be x equals 1. And the reason for that is because the area under the positive, or the positive f of x is greater than the area under the negative f of x. And what we're really saying there is we increased a lot more than we decreased. Alright guys, when you're studying for your test, don't forget your integration rules. Those are in 6.2. It's just the chart in 6.2. Don't forget about your LRAM, RRAM, MRAM, just those basic things, and you should be good. Alright, good luck.